Why would one airplane stop a pilot from making a dangerous move, while another allows the pilot to do it and only sounds an alarm? This difference is not accidental, and it is not about one company having better technology than the other. It comes from two very different beliefs about how humans behave under pressure and what role an airplane should play when things start to go wrong. Airbus and Boeing both build some of the safest machines ever created. Both rely heavily on automation, and both trust their pilots to be skilled professionals. Yet, when danger appears in the cockpit, they respond in very different ways. Airbus designs its aircraft to protect themselves from unsafe actions, while Boeing designs its aircraft to warn pilots clearly and then give them the authority to decide what to do next. Understanding why these two companies made those choices helps explain many of the debates, training differences, and accident analyses seen in modern aviation. At the heart of this difference is trust, but not trust in the way it is often discussed. Airbus and Boeing both trust pilots, but they trust them in different moments. They also trust computers differently, especially when time is short and stress is high. Airbus begins with a hard reality about human behavior. Even highly trained pilots can make serious mistakes when surprised, overloaded, or confused. In those moments, the brain may react before it fully understands the situation. A sudden pull on the controls can feel right, even when it is exactly the wrong thing to do. Airbus engineers believe that if the airplane already knows a maneuver is unsafe, it should not allow that maneuver to happen at all. This belief led Airbus to design aircraft that actively protect themselves. When a pilot moves the side stick, the input is treated as a request rather than a direct command. Flight control computers check airspeed, angle of attack, bank angle, and structural limits before deciding how the airplane will respond. If the requested action would push the aircraft into danger, the system simply refuses. Pulling harder does not change the outcome, because the airplane will only give as much performance as it knows is safe. Under normal conditions, this means an Airbus cannot be stalled by pilot input alone, cannot overspeed, and cannot exceed its structural limits. The airplane acts as a barrier between human reaction and physical disaster. Airbus believed that preventing certain mistakes entirely was safer than relying on a pilot to recover from them after they had already begun. Boeing starts from a different belief about risk. Boeing agrees that humans can make mistakes, but it also believes that rare situations exist where rigid rules can become dangerous. A computer sees data, but a pilot sees context, environment, and intent. Boeing engineers worried about the moment when a pilot might need to do something unusual to survive, only to have the airplane refuse because it does not fit a programmed rule. Because of this, Boeing chose to preserve pilot authority. In a Boeing aircraft, when a pilot moves the control column, the airplane responds directly. Computers assist by smoothing movements, improving stability, and helping with trim, but they do not block control. If a pilot keeps pulling back, the airplane will keep pitching up. The system will warn loudly and clearly through alarms, stick shakers, and alerts, but it will not physically stop the pilot from acting. This approach reflects Boeing's roots in military aviation, where pilots are trained to feel the aircraft and make judgment calls under pressure. In a Boeing cockpit, the controls move and push back. Resistance increases as limits approach, and aerodynamic loads are felt through the hands. Boeing believes that this physical feedback helps pilots understand what the airplane is doing and recognize danger before it becomes unrecoverable. Because Airbus and Boeing fear different types of failure, they design for different risks. Airbus fears the sudden, irreversible mistake that happens during startle or confusion, while Boeing fears the lock system that refuses to help when a pilot needs flexibility. Both fears are valid, and both have shaped decades of design choices. A useful way to think about this difference is through everyday safety design. Airbus is like a guardrail on a mountain road. It may allow contact, but it physically prevents a vehicle from going over the edge. Boeing is more like a warning sign and a rumble strip, alerting the driver that danger is near while leaving control of the steering wheel in human hands. One system prevents the worst outcome by force, while the other relies on awareness and judgment. The difference becomes especially important when automation disconnects. Most modern flights are flown with autopilot engaged, with pilots monitoring systems and managing decisions. Automation reduces workload, but it does not remove responsibility. When something unexpected happens, control returns to the pilot instantly, and that handover moment is where design philosophy matters most. An Airbus pilot often expects the airplane to protect itself, while a Boeing pilot expects the airplane to obey. If those expectations are wrong, confusion can begin quickly. This was tragically demonstrated in the case of Air France Flight 447 in 2009. An Airbus A330 flying at night over the Atlantic encountered unreliable airspeed readings due to ice crystals blocking the pitot tubes. The autopilot disconnected, and the aircraft reverted to manual flight. The pilots, suddenly flying by hand at high altitude with little visual reference, pulled back on the side stick. Under normal conditions, Airbus protections would have prevented a stall, but because sensor data was unreliable, the airplane changed control modes and some protections were lost. The aircraft climbed, slowed, and entered a deep stall. Because the controls did not strongly resist and the airplane remained relatively calm, the crew did not recognize the stall in time, and the aircraft fell for several minutes before impact. This accident was not caused by Airbus protecting the aircraft, but by a misunderstanding of when that protection was available. The danger was not automation itself, but confusion about how the system behaved when conditions changed. Boeing accidents often show the opposite pattern. In Boeing aircraft, the airplane continues to obey pilot input even when it should not. Accidents often involve pilots being overwhelmed by warnings, workload, or time pressure, while the airplane faithfully follows commands. In these cases, the system trusts the pilot too much rather than too little. This highlights an important truth about automation. Automation does not eliminate accidents. It changes how they happen. Airbus-related accidents often involve confusion about modes or protections, while Boeing-related accidents often involve human overload or delayed response. Neither philosophy removes risk entirely. Each one shifts it to a different place. Feedback is not about comfort. It is about information. Airbus delivers information digitally, while Boeing delivers information physically. Each approach has strengths and weaknesses, especially under stress. Over time, both companies have learned from accidents and incidents. Boeing has added smarter warnings and limited protections, while Airbus has improved alerts, displays, and pilot awareness. The gap between the two approaches has narrowed, but the core beliefs remain the same. Airbus still believes safety comes from preventing dangerous actions before they occur, while Boeing still believes safety comes from informing the pilot clearly and trusting judgment. Neither approach is reckless, and neither is perfect. They simply answer a different question about human and machine interaction. Should an airplane stop you from making a mistake, or should it trust you to correct it? Every flight today carries that answer into the sky. In an Airbus, the aircraft stands guard. In a Boeing, the aircraft speaks up and steps back. The future of aviation will depend on how well humans and machines continue to decide where that line should be. If this helped clarify why Airbus protects the aircraft while Boeing warns the pilot, like the video so other aviation fans can find it. Subscribe for more clear, thoughtful aviation stories and share this with anyone who thinks warnings and protections are the same thing.